Hi to everyone! In this video, we are going to discuss the limits of exponential, logarithmic, and trigonometric function. The objective of this lesson is to compute the limits of exponential, logarithmic, and trigonometric functions. Limits of exponential functions. Suppose b is greater than 0 and the limit of f of x or x approaches to a is equal to L, then the limit of b raised to f of x where x approaches to a is equal to b raised to L. Finding the limit of exponential function is similar in finding the limit of other algebraic functions. The theorem can be simplified as the limit of b raised to x where x approaches to a is equal to b raised to a. Let's have an example to understand the theorem. Find the limit of 3 raised to x where x approaches to 4. By substitution, x will become 4. So 3 raised to 4. 3 raised to 4, that is equivalent to 3 times 3 times 3 times 3, which is equivalent to 81. The limit of 3 raised to x or x approaches to 4 is equal to 81. Number 2. The limit of 5 raised to 2x minus 1 where x approaches to 2 is equal to 5 raised to 2 times 2 minus 1. X become 2. Then simplify the exponent. 2 times 2, that is 4. 4 minus 1 is equal to 3. 5 raised to 3, that is equivalent to 125. Because 5 raised to 3 is equivalent to 5 times 5 times 5. 5 cubed is equivalent to 125. So the limit of 5 raised to 2x minus 1 where x approaches to 2 is equal to 125. Example number 3. The limit of 2 raised to x where x approaches to negative 3, x will become negative 3. So 2 raised to negative 3. Applying the law of exponent, negative law of exponent, negative exponent, so that will become 1 over 2 raised to 3. 1 over 2 raised to 3 is equivalent to 1 over 8. The limit of 2 raised to x where x approaches to negative 3 is 1 over 8. Number 4. The limit of x minus e raised to x where x approaches to 2. So just simply substitute 2 to x. So the function will become 2 minus e raised to 2. That is now the answer. Number 5 example. The limit of 1/4 quantity raised to x plus 2 where x approaches to 1. By substitution, x will become 1. 1/4 quantity raised to 1 plus 2. And this is equivalent now to 1/4 quantity raised to 3. So 1/4 quantity raised to 3, that is 1 over 4 raised to 1 raised to 3, 4 raised to 3. Okay, so 1 raised to 3 is 1. 4 raised to 3, that is 4 times 4 times 4, 64. Number 6. The limit of 4 raised to x minus 1 over 2 raised to x minus 1 where x approaches to 0 by direct substitution. 4 raised to 0 minus 1 over 2 raised to 0 minus 1. 4 raised to 0, that is equivalent to 1. 2 raised to 0, that is also equivalent to 1. In law of exponent, 0 exponent always equivalent to 1. So simplify this, 1 minus 1, that is equivalent to 0. 1 minus 1 in the denominator, that is also 0. So this is in the terminate. Okay. If we're going to solve by direct substitution, it will become 0 over 0 or indeterminate. To solve this, we are going to factor the numerator and simplify before substitution. So limit of 4 raised to x, that will become 2 raised to 2x minus 1 over 2 raised to x minus 1, where x approaches to 0. Factor the numerator. So limit of the quantity of 2 raised to x minus 1 times 2 raised to x plus 1 over 2 raised to x minus 1, where x approaches to 0. Then, cancel 2 raised to x minus 1. So the remaining term on the function is limit of 2 raised to x plus 1, where x approaches to 0. Then, we can now use direct substitution. So x will become 0. So 2 raised to 0 plus 1. 2 raised to 0 is equivalent to 1 plus 1. Limit of logarithmic function. Suppose L is greater than 0 and the limit of f of x, where x approaches to a, is equal to L. Then, the limit of ln f of x, where x approaches to a, is ln L, and the limit of logarithm of f of x to the base b, where x approaches to a, is equal to logarithm of L to the base b. The theorem can be simplified as the limit of ln f of x, where x approaches to a, is equal to ln of f of a. And the limit of logarithm of f of x to the base b, where x approaches to a, is equal to the logarithm of f of a to the base b. To understand this limit of logarithmic function, let's have examples. Number 7. The limit of logarithm of x plus 15 to the base of 4, where x approaches to 1. So x will become 1. So the logarithm of 1 plus 15 to the base of 4. Simplify this. We have logarithm of 16 to the base of 4. Logarithm of 16 to the base of 4, that is equivalent to logarithm of 4 squared to the base of 4. So this is now equal. So the answer here, logarithm of 4 raised to 2 to the base of 4 is 2. The logarithm of 4 raised to 2 to the base of 4 is equal to 2. Number 8 example. The limit of logarithm of 2x minus 5 to the base b, where x approaches to 3. This will become logarithm of 2 times 3 minus 5 to the base of 2. So x will become 3. So 2 times 3 is 6 minus 5. So 6 minus 5, that is 1. The logarithm of 1 to any base is always equal to 0. So the limit of logarithm of 2x minus 5 to the base of 2, where x approaches to 3, is equal to 0. Example number 9. The limit of logarithm of 5x minus 7 to the base of 2, where x approaches to 3, is equal to the logarithm of 5 times 3 minus 7 to the base of 2. So x becomes 3. We use direct substitution to simplify this. 5 times 3 is 15 minus 7. So logarithm of 15 minus 7, that it will become logarithm of 8 to the base of 2, because 15 minus 7 is 8. Logarithm of 8 to the base of 2 is equal to the logarithm of 2 cubed to the base of 2. We express 8 to exponential form. So the logarithm of 2 raised to 3 to the base of 2 is equal to 3. Example number 10. The limit of logarithm of 3x minus 5 plus 2 to the base of 2, where x approaches to 2, is equal to the logarithm of 3 times 2 minus 5 plus 2 to the base of 2. Simplify. This will become logarithm of 3 times 2 is 6 minus 5 to the base of 2 plus 2 logarithm of 6 minus 5 is 1 to the base of 2 plus 2. So the logarithmic expression only here is this one. Logarithm of 1 to the base of 2 is equivalent to 0 plus 2. So 0 plus 2 is equal to 2. So the logarithm of the limit of logarithmic of 3x minus 5 to the base of 2 plus 2, where x approaches to 2, is equal to 2. Number 11 example. The limit of logarithm of 2x minus 7 raised to 4 to the base of 3, where x approaches to 5. So this will become equal to logarithm of 2 times 5 minus 7 raised to 4 to the base of 3. So let's simplify this. 2 times 5, that is 10, minus 7 raised to 4 log to the base of 3. So 10 minus 7 is 3. So that is logarithm of 3 raised to 4 to the base of 3. Logarithm of 3 raised to 4 to the base of 3 is equivalent to 4. So the limit of logarithm of 2x minus 7 raised to 4 to the base of 3, where x approaches to 5, is equal to 4. Limit of trigonometric function. Limit of sine x, where x approaches to a, is equal to sine a. The limit of cosine x, where x approaches to a, is equal to cosine a. The limit of tangent x, where x approaches to a, is equal to tangent a. Then the limit of cotangent x, where x approaches to a, is equal to cotangent a. The limit of secant x, where x approaches to a, is equivalent to secant a. The limit of cosecant x, where x approaches to a, is equal to cosecant a. Let's have an example. The limit of sine of x plus pi over 2, where x approaches to 2, is 0. Example, the limit of sine x plus pi over 2, where x approaches to 0. So substitute 0 to x. So this will become sine 0 plus pi over 2. Then 0 plus pi, that is equivalent to pi over 2. What is sine pi over 2? Sine pi over 2, that is equivalent to 1. because this is 90 degrees. Sine 90 is 1. Example number 13. The limit of 2 sine x minus 3 cosine x where x approaches to pi. So evaluate 2 sine pi minus 3 cosine pi. Copy 2. Then find the value of sine pi. Sine pi is equivalent to 0 minus 3. Then what is cosine pi? Cosine pi is equivalent to negative 1. Then simplify. 2 times 0, that is equivalent to 0. Negative 3 times negative 1, that is positive 3. So the answer here is positive 3. The limit of 2 sine x minus 3 cosine x where x approaches to pi is equal to 3. Number 14. The limit of cosine x over sine x minus 5. Cosine x will become cosine 0 over sine 0 minus 5. What is cosine 0? Cosine 0 is equivalent to 1. Sine 0 is equivalent to 0 minus 5. So, simplify the denominator. The answer here will become 1 over negative 5. So, the limit of cosine x over sine x minus 5, where x approaches to 0, is equal to negative 1/5. More example in trigonometry. The limit of 2 cosine x plus 2, where x approaches to 3 pi over 4. By direct substitution, this will become 2 cosine 3 pi over 4 plus 2. What is the value of cosine 3 pi over 4? That is equivalent to negative square root of 2 over 2. Then multiply it to 2. Cancel 2. So this will become negative square root of 2 plus 2. This is now the answer. Or you can write 2 minus square root of 2. So that is the limit of 2 cosine x plus 2 where x approaches to 3 pi over 4. Number 16. The limit of cosine squared x over 1 minus sine x where x approaches to pi over 2. Let's substitute. So the limit will become cosine squared x where x approaches to pi over 2 over 1 minus sine pi over 2. So what is cosine squared pi over 2? This is the same as cosine pi over 2 times cosine pi over 2 over 1 minus sine pi over 2. So cosine pi over 2, that is equivalent to 0. So 0 times 0, that is 0. In the denominator, we have 1 minus sine pi. The value of sine pi is negative 1. So this will become 0 over 0. And this is indeterminate. So what are we going to do? We're going to simplify this trigonometric expression before we substitute pi over 2 to the function. So this will become limit of cosine squared x. So that is equivalent to 1 minus sine squared x. This is a Pythagorean identity. Copy the denominator 1 minus sine x, where x approaches to pi over 2. Factor the numerator. 1 minus sine squared x is equivalent to 1 minus sine x times 1 plus sine x over 1 minus sine x, where x approaches to pi over 2. Cancel 1 minus sine x. So the remaining term here is 1 plus sine x, where x approaches to pi over 2. Then we can now substitute pi over 2. So the limit of 1 plus sine x will become 1 plus sine pi over 2. Sine pi over 2 is equivalent to 1. So the final answer is 1 plus 1 is equivalent to 2. So the limit of cosine squared x over 1 minus sine x, where x approaches to pi over 2, is equivalent to 2. That's all. God bless to everyone.